Hello, everyone, and welcome to this acceleration event for Epidemium. We are very pleased to host you in numbers physically first, and of course online too. This is one of the first real events where we would be able to bring up everyone and have also scientific experts to be here to answer your questions. So very quickly, we will jump to the program. And we'll propose you a quick introduction where we'll remind you a few aspects of the program already initiated and a few updates, specifically the timeline. Then we will have a quick review of the first challenge, ENTEA, with Professor Cecile Badoual, who joined us. And then a short reminder also of the stakes and a few updates on the second challenge, concerned environment. And then, of course, we'll be up to the core event with the testimonials first of Christian from the EPITA, and then Edouard, participant from the first season, will explain us how he managed to drive a team of 120 people. So it would be really interesting to get information on how this happens for him in the first season. Then your interventions. I will finish with what we call the crew exchange. It's a term, if you navigate a bit, that will be maybe relevant to you. The idea is maybe that you will want to jump with a few teams that will have presented what they do during this event. So let us know on the chat when we will get there. So just to remind for the one of you that might join us just now that Epidemium Challenge is still open, it's still a data challenge, and is still based on community. We are a few people to try to foster this event and this specific data challenge. We of course have Olivier, Mehdi, Aude, who prepared the whole program, Alexandre, related to the data preparation, and Jonathan for all the legal aspects. Our partners this season are mainly Roche, where we have this event today. And then we have CancerBaseline, PHP, Curie Institute, Just One Giant Lab for the technical partners, and Octopi for the data anonymization. DATATEGY, of course, is also providing a place where we host data and where you will be able to launch your algorithms. So thank you to everyone. What do we expect if you join us for this season? Last seasons were oriented in demonstrating what could happen if you foster a large community, if you have a large network of partners and try to work with newly open data sets. So I think the two last seasons were really a big success into this direction. And we aim more than ever to be able to foster publication in medical journal with the help of the scientific partners for this season. How would you participate? Of course, if you are here, it's highly probable that you already have joined one of those tools, but we just remind you that you could create a profile on app.juggle.io, which is the main place where you can jump to the projects being created and exchange with us on the Slack platform, and also be aware of all upcoming events with the Meetup website, where you have everything that is forthcoming. You can, of course, then access the tools where you have all the data. We wanted to share with you a big update. We decided to extend the date of closing for Epidemium Challenge Season 3 because of many reasons, mainly the schools that wants to jump in the program this season, and that will be more pleased if we deliver something also for their students finishing during mid-January. So basically, you have to keep in mind that the 12th of January will be the date where the challenge will be closed, and then the closing event will happen the 19th of January, while in the meantime, the date of the 25th of November is maintained for a second acceleration event like this one, where we'll invite you to meet with experts and have feedbacks from them. A short word about evaluation. We'll get back to this after, but the main idea is that this project is completely open, so you will be evaluated on what you publish. What you publish is what you can document. We invite you to publish on your own GitHub or GitLab account, and this is exactly where we will look at your productions at the end of the challenge, which means that you already can start something if you already have accounts on GitHub or GitLab and publish what you did so far, which will help us to guide you into the whole process of creating your projects. Who will evaluate you at the end of the day will be the Ethic and Scientific Committee. They are the jury for this challenge. What will they base their evaluation on? This little grid we will, of course, share with you on the Juggle website. You have more insights, but basically, we have the originality of the project, the methodology, the fact that you have managed to foster different expertise into your project, and of course, mainly the impact on patient health, and the different perspective we can give to your projects. A few prices will be proposed and decided by the jury at the end. A very short review of what has happened yet. You have the idea of the frequency of events we delivered. Here we have almost 15 events since the beginning of September. So we have a lot of moments where we try to make you meet other participants and try to help you into the technical challenges and the medical challenges of this program. Basically, you have those core events you can find that are registered and that you can access to on the YouTube platform. The talks also, you can find it on the YouTube channel of Epidemium, and all the community events that are more informal, where you meet within each other's. And thank you again, Paige, for the animation of the acceleration weekend last week, where we had opportunities to create a few new teams. So that's really nice for this. How many participants are we dealing with right now? The count just updated recently, so we are more about 65, very close to 70, really. But this is so far almost 61 participants. Few of you already positioned themselves on a specific challenge, but many of you are expecting some teams to be here to guide and to help. So that's also a challenge of today, for today, maybe to hear a few presentations and to maybe join a project that is already launched. That's the idea of those acceleration events. And we finally have quite a lot of teams already created for the challenge 1. So we have 7 teams created or in creation. And for the challenge 2, we actually have mostly 2 teams, with one that we will probably propose you to chunk into more small bits, and we'll get back to you on this topic before the end of the sequence. What type of profile do we have yet? Sorry for the cranky look of this diagram. I just added very quickly before the presentation, but it's quite a mix, interesting mix of data science and medical profiles. I would say we have a little bit more medical profiles than the last seasons, to be confirmed. But of course, we will do the math at the end of the sequence. A very quick reminder of upcoming events. So this is based on the timeline I just shared with you before. We have core events the 25th of November, of course, which will be a second event like this one, where you can expose what you did so far on the projects. And then, of course, the closing events that will be a big moment with presentations. Different talks to be announced. We have a formation from DATATEGY, an intervention from the French Ministry of Environment about their project Green Data for Health, and some insights from HPV with CapCode that proposed an intervention on this very specific object. Basically, something they did from Twitter, a very interesting project. They will talk to you more during the community events to come. We have a community event every Wednesday so far. We have people coming at each time, so that we will maintain this frequency. Next one will be next week, with a small typo, sorry about that, November the 3rd. I'll now invite Professor Cecile Badoual to give us a few reminders about the stakes of the Challenge 1. A few insights maybe on what changed on the available data and what is happening right now. And a question also from the participants, which is related to how projects are accompanied. This is something we explained already, and maybe will be accompanied toward publication during this challenge and maybe after. Then we'll have a reminder also from Mehdi Benchoufi, scientific lead of Epidemium program, on how specific evaluation will be made on this challenge. So Cecile, are you with us?
Yes, of course.
Yes, thank you for being here. So yes, the idea is that maybe you can answer the questions in the order you are comfortable with. If you have some slides to share, of course, you can maybe take the
yeah, well, I prepare the same slides I just showed. We can just focus on the question with the help of the slides, but I can't put my slide. Can't find where the.
This is because I have to stop my presentation probably from my side before you.
No, I can't find where we can. Ah, okay. Is that okay?
Yes, perfect.
Okay, so what do you want me to do? To just present and then have the question after, or have the question and try to find where I can find answer in my slides?
Maybe it will be easier if we take the question after, because.
Okay, so I will go quick about the challenge. It's about ENT, so ear, nose, and throat cancer and AI. It's about the fact that in some cancer, mainly focused on oropharyngeal cancer, they are due to alcohol, tobacco, but also HPV. And HPV, the human papillomavirus, found in many cancers. The main cancers where you can find HPV are cervical cancer, vulvar cancer, vaginal, anal. But I go through all of these because it's not the focus of the question for now. But so you have some oropharyngeal cancer. Oropharynx is located at the at the back of the mouth. You can see the tonsil and the tongue base, and they are all both of them are involved in the oropharynx. So there are more and more cancer due to an HPV infection all over the world. And you can see in this map that the cancer where we can find this cancer, the countries where you can find mostly this cancer are located at the north of the map. So there's an increase of oropharyngeal squamous cell carcinoma, OPSCC, because the squamous cell carcinoma is the main histology, the main type of histology you can find in this cancer. So it's all squamous cell carcinoma. And some of them are due to HPV and other no. And well, some people say that now there's a pandemic due to HPV, mainly located in the oropharynx. So, what is the standard patient having a cancer due to HPV in the oropharynx? They are small tobacco and alcohol consumption. It's sexually transmitted, and mostly we can find the HPV 16. And the importance of the cancer due to HPV is depending on the country, but roughly you can have half of the cancer, 30 to half of the cancer, or even 80% of the cancer are due to HPV in the oropharynx. So the question, and these cancers are associated with a better prognosis. So this question is, among these cancer due to HPV, some of them have a good prognosis, and other are a worse one. But normally they all have a good prognosis. So we think that all the immune cells, meaning lymphocytes and macrophages all around the tumor, could be there's a problem, no? Could be involved in the carcinogenesis, stopping or helping the tumor cell spreading. So you will have for the challenge different cells, the pro-tumoral one and the anti-tumoral one, all around the tumors. So the goal of your challenge is to try to find if some cells are associated with better or not, or if we can have signatures of different immune cells, but you don't know the name, you just have the images. So we made multiplex staining with immunofluorescence. We used antibodies, and then we had different patients, and you had 1 to 4 stamps to allow you to just focus on the different cells all around the tumor. Here we are. You have a plain slide, but you have a small square showing the different stamps we provide for you. And for the different staining, you have 7 staining, inflammatory cells 1 to 6, and then tumor cells to just find if you have immune cell all around the tumor, and if they are just in the different tumor node. Focus. And you will have 6 images and the tumor cells. And sometimes the same the same staining could be found in different tumors, different cells. So this is inflammatory cells, for example. You can find the different cells, other staining, and you've got plenty of these different cells in the data set you have. So you can find the different cells, but you have to pay attention to the fact that you've got a cytoplasmic staining just all around the tumor, or nuclear staining. It's in the center of the tumor, it's the nucleus. So the tumor cells are there, mostly enormous. And then you've got also the tissue segmentation. And this tissue segmentation can just show you where is the stroma, where you can find the immune cells, and where are the tumor. But you also can find immune cells in the tumor. The DAPI is really important. It's the correlation of the DNA. The DNA shows the nucleus. So for each dot, you've got a cell. So if you do have staining without any DAPI dot in the center, so it's not a cell. So you have to avoid this staining. You always have to focus on the fact that you need to have a DAPI staining in the center of your cell. So you also have clinical data. You've got the outcome of is does one of or a combination of immune cell staining in the stroma or in the tumor correlated with a better prognosis for the patient and the better patient survival, and is it a prognosis factor also? So you will have staining expressed in density, number and area in the stroma and in the tumor. Survival expressed in overall survival in months, and overall survival is the last new upon death state, and well, or biopsy date. And because, well, sometimes you just have the survival. And disease-free survival is recidive among the last news or death or biopsy date. So you also have age, WHO classification. It's the general health condition, TNM, staging, the node, the tumor, the metastasis, because it's the size and the extension and the invasion of the tumor, and alcohol and tobacco consumption. All these clinical data could be based for your research. So be careful with this information. And also, you will have we will have provide you a score, the RNA score. It's an in situ hybridization, and you have the importance of the transcription of the mRNA of the HPV. Meaning 0 is very low or PCR, HPV PCR positive. So there are some HPV, but in different levels. So in conclusion, a staining or a combination of immunocell staining, meaning a signature, could be found, and it's important to see if it will correlate with a better survival and a better prognosis. We could at least find factors that are involved in the modulation of the treatment and the care, and to help us to target the immunotherapies. Thank you.
Thank you, Cecile. I propose you, maybe if you have questions, to ask them on the chat, and then we will see which one we can take right now or maybe afterwards. Meanwhile, maybe can make a quick reminder on how this challenge will be specifically evaluated, while you maybe write a few questions. We won't have maybe time to take all of them, of course, just the ones that may be more shared with what we have seen yet. And yes, we of course get back to you if you have questions that hasn't been answered today. Thank you.
No question.
Okay. Hi,
yeah,
yeah, I think there are already hands that are raised. Thank you, Cecile, for this overview of this very challenging challenge. I think it's very important from public health point of view, as Cecile sketched it, and also it's quite challenging because it's rather difficult, and people who will be able to score here will be really of great help to the medical community. So basically, talking the data science small talk, it's about a classification problem which basically is quite simple when we look at the outcome. The outcome is the OS, the overall survival. In general, what is tricky is the input, and here the input is especially tricky since you have clinical data, you have images, but images come with the stains, which make it quite difficult from a statistical point of view to take it into account, since the information related to any stains are correlated, they are strongly dependent. And so that's it for the challenge one. And again, it is a classification problem. And here we have to get the overall survival as the outcome with regard to the income, which are inputs being clinical data and imagery with stains.
Perfect. Maybe first comment on the leaderboard present on the DATATEGY platform. I know there's a question related to that from a few participants. How does it work, and how this evaluation will be set?
So maybe I can hear Alexandre. You want to add some points on the leaderboard? So
Actually,
go ahead.
Yeah. Actually, we detailed it in the video explaining how to use DATATEGY. You can access it in the flow in your project, and then you have to click. You have to roll down the menu, and at the bottom you have a little icon called "Get Your Score" with a cup, and afterwards. But I think the best way is to look at the tutorial on the video, because you can have the visual with it, and it will be more explanatory. Because if I try to explain how to access the macro without showing it, it's not very visual.
Sure.
Rachel, there's one question from Rachel about the anonymization of the data. So normally, we hope so, there's no modification of the profile of the patient.
It was just unusual during the presentation about the anonymization. The guy made it sound like each row was sort of swapped around randomly. So the people didn't have their correct age. It didn't say if they had really were cigarette smokers or not. But I guess the most important thing is just if they survive or not.
Didn't really get if there is a question. Sorry, I can't hear much of what you say just here. So
my question is only if the data that's given for the clinical data, if it's all relevant for the given images with its avatar code.
No, well, for example, tobacco and alcohol consumption is very important, because when there's a stratification among the HPV positive patient, when you are a smoker, you have a worse prognosis than when you do not smoke. So it's important. For example, when you so all the data has an importance, but not in the same level. But yeah,
that's exactly what I thought too. But when they gave the presentation about how they made these avatars with their anonymized numbers and so on, they said they swapped all the columns of the data around too. So maybe it would just be really provide confidence if you could go and double check that actually it says the right thing.
We have to focus on that. Okay, thank you.
Thank you. I see a few questions.
Yeah, sorry, just to add one point, complementary point about the fact that obviously the people that will be able to get the right scores if we can define some, will be invited to counter, so to stress test their own algorithms on the data that Cecile is providing, so that there will be an after challenge. And the second thing, just to say that obviously what we require at minimum is to get the right performances from the outcome point of view. And if by any chance people are able to make some kind of feature interpretability to understand how the algorithm is taking its decision, let's say into quotes, would be really, really helpful. So the interpretability, which is not by design something like that we take care as the jury will have to take this decision, but from a medical point of view, it's extremely relevant to not let it as a black box, but to put a layer of interpretability.
Okay, thank you. Thanks a lot, Cecile. If you have questions, I see a few of them in the chat, but I can read them from here. So I propose maybe we take them and we get back to this before the end of the session if we can, or we get back to you directly after this moment and this presentation. Guillaume, did you have a question or was it?
No, sorry.
Okay, thank you. So maybe I'll invite Bastien to make us a few updates on what we were talking about.
Yes, so thank you very much. So I will speak about the second challenge and maybe just do a sum up of where it come from first. So why we are here is because of Epidemium season 2, I believe, because there was some work done on cancer and open data, and we were very interested in that. And so Olivier at this time invited some people from HCGP, the Pompidou Hospital in Paris, to come see what had been done. And we thought, oh, well, that's interesting. We don't use a lot of open data within the hospital, and there is probably an opportunity of doing something with open data and private clinical data inside the hospital. At this time, what had been done was at a national level. So it was data from states, France, Belgium, US, and so on. And that's not the level at which we work. We work, of course, on private, very precise data, and we could not just exchange the methodology this way. So that's why we started working with Epidemium on this challenge. So basically, we work in the context of the CancerBaseline Île-de-France, which is an institution that is here to engage the different partners, which are a research institution and care institution around the Paris, the Great Paris area, in helping them doing research and collaborate with each other. And we are member of the working group GeoCancer of the CancerBaseline Île-de-France. And this working group includes centers such as the APHP and the HCGP Hospital, but also the Curie Institute, the Gustave Roussy Institute, so lots of organization in that. And we worked mainly on using information, geographical information, to bring more information within the hospital. So when we started working on that, the COVID pandemic struck, and we used what we had started to do on the COVID, and one of the results we worked on was trying to see what was the influence of the region, the neighborhood in which you live, on your risk of being hospitalized. And actually, the result was striking. If you live in a poor neighborhood in Paris, you have 4 to 6 more times more risk to be hospitalized than if you live in a richer area. And so it's known that it's very interesting to do that kind of analysis for many things. So basically, there are precious informations to be found in open data and specifically in geodata. These information are actually starting to be used in the day-to-day care of patients, because you need to personalize. Well, the movement in medicine is to do personalized medicine, so to adapt the treatment to the right person at the right time, and so there is many dimension. And of course, there are social, environmental aspects to that as well. For example, you will not treat, maybe you should not prescribe exactly the same thing to a patient who lives in a neighborhood with a lot of liberal nurse or lots of care facility. Or if you treat somebody who has no care facility at all in their neighborhood, maybe you will have them hospitalized instead of having day-to-day care in a facility, something. So basically, this information can be used in everyday care. But also for research, I gave you an example. In COVID, in cancer, the social aspect is very important. The environmental aspects as well, with exposome, the pollution, the chemicals, and so on. And so we have a challenge here as researcher, is that there are tons of open data available, but these data are pretty hard to find and to use. And basically, what we would like is an increase of the usability of the data that are available. And maybe a good way to think about that is thinking of the FAIR, I don't know if you know that, the FAIR values, which is findable, accessible, interoperable, and reusable data. So it's a way to describe data that will ease the exchange and the reuse of this data. And one element, for example, is to use standard terminology, or to use reusable identification URIs and that kind of thing. And that's not always what's present in open data. So one way to do that would be to provide better metadata, to complete metadata, to have standardized metadata, to align what can be found within the content of data itself with standard vocabulary, ontologies, maybe things that needs to be designed. And it's, I think, the link with another part of the challenge, which is the link with OSIRIS, the OSIRIS group. And OSIRIS is a working group from the French National Institute on Cancer, which involves partners at the national level, and which goal is to produce minimum data sets to help exchange of data and research in oncology around clinical data and omics data. And very clearly, we have this need to put that further within the context of open data. And so, yeah, and so if I just go back to everything, basically, we have lots of data, but we don't know how to use them. We cannot query them in an easy way. Once we can query them, we are not always, it's not always easy to find them. So that's many dimensions on which we would like to work. And there are many challenges that can be identified. And we have not just took one, because basically everything could be interesting for us.
Maybe a point we also talked about recently is how to open. Thank you. One of the questions we had, participants had also, is maybe how to start, how to operationalize the beginning of the question. We talked about, for example, the open data Paris data sets. Maybe you can have a few words about those first steps for the one who is still trying to.
Yeah. So one thing we mentioned was maybe do a first description of the metadata available today. So to see what kind of thing can be found, is it standard or not at all, to have a kind of an overview of the state of open data. That could be interesting for us. So what could be interesting, anything that is linked to health or environment, basically, or social aspects. And yeah, that would be a first step. That is not too hard, but that would be very interesting because it would tell us where we are and where we would need to go.
And there could be also an interest from international participants, maybe to do this
Yeah.
job on their own country's dataset,
Yeah,
open dataset.
yeah. So one thing also is if we want to be able to do studies involving open data at an international level, we need to be able to have our dataset that can communicate. And one way to do that would be to use standard vocabularies that are shared, so ontologies that would be shared across countries, and to have a way to map our standard metadata, for example, to the metadata from other countries. So that's two ways to start the challenge. So first to do an overview, and the second one is to work on that ontology aspect and mapping internationally things. So multilingual and everything.
Thank you very much. Something to add maybe, or that's good for you?
I don't know if we have questions. I can't.
Yeah,
see
you
where-
can maybe write a few questions in the chat if you have questions on this specific challenge. While maybe you can add up a few things. Maybe the idea that we get back to the grid for evaluation specifically on this challenge, it's not linked to the leaderboard, but maybe you want to to explain how we evaluate finally this challenge.
Yeah, thank you. Here, obviously, the way will be like analyzing the results, also the proposition of the challengers will be more qualitative than obviously for challenge based on, let's say, a simple outcome and simple statistical performances like the challenge one. Here we have mainly two tracks that the challengers can take their way on. There is the way to go through the ontology side, or the way to make to provide query tools, both leading to a data set that will be submitted. So as you explained, obviously what we're saying here in this challenge is that open data is not enough. There has been 10 years of strong efforts of communities to make it fair, like you said it. And maybe for the R of reusable should be the R of relevant, which is really hard to get to the data, to the relevant data. And so to, let's say, to value the proposition of the challengers, will get mainly on two criteria. The first one is, let's say, criteria, basically qualitative criteria on the originality of what will be proposed to us, on the rigor of what is proposed to us, and this will be appreciated by the jury. And on the other side, we will appreciate also the potential of use and reuse of what will have been done, either from the ontology side or from the query side. They will be the two main aspects on which we'll be waiting for the challengers.
I didn't see any questions from where I stand. Maybe Camille, or have you have access to the chat or page? Maybe do you see any questions?
We have a few questions, yes, from those were from Edouard. So just to confirm, there are 69 people, and do we think it's enough to find explanatory factors for prognosis?
But this one was probably
For
linked to
challenge
challenge one.
So yeah, maybe I can take it here right away. So definitely, I said that the challenge is challenging, and basically we have a very incredible data set that Cecile constituted with composed with her team. The fact is that these are very special data, but it comes with a flow, which is that we have not a huge database for sure, and it's one aspect of the challenge. And let's say that this last year's, from the data science point of view, there have been a lot of people working especially on this aspect. How can we put some performance on algorithm performance when the data is rather scarce? which is basically at the very beginning, but I won't be long on this. The very beginning of the big data is this, is that when we have a small sample size and we have a huge number of parameters, this is the very definition of the big data.
Yeah,
Otherwise,
I can add that you've got billions of cells to explore. So
yeah, that's the thing. And this is where we're waiting for the challengers. And, you know, when you have not as much data, let's say independent data, when you have several sample size where the data are independent, then you have to be smart, and you can make a lot of data augmentation, and there are a lot of on-the-shelf techniques to do that. And as Cecile said, obviously there are millions of cells. They are statistically to be considered because they are correlated, obviously, but it's up to you guys to surprise us.
Thank you. Maybe a question on challenge 2? Not specifically. Rachel, maybe, yeah?
I was just wondering, where is the data for challenge 2?
So the data is everywhere. Since it's open data, the data is distributed on the web, so you can go and fetch any kind of data sets on which you can build your ontology or on which you can build the query tools. This is up to you. You are totally free to get to it. We suggested to use, for instance, the data of EPITA, which is the French open data site, which is really well done, really well done. But otherwise, you can go to the UK one, to the American one, the Canadian one. Let's say that's pretty much all the open data sets in the world, the public institutional level data sets are based on the same framework, which is called CCAN, so that when you go to a country or another and an institution to another, it's basically the same way, the same way the data is spread and organized on the website. So you're pretty much free to go and fetch any kind of data. And maybe I can add a little point, because this is a personal point, but I stated the challenge to be, whether you go to the ontology side or whether you improve the query tools. I think that's one basic stuff could be for, let's say, EPITA Lab or some kind of alike website. Get the data and flatten the data. And this will make all the data of EPITA Lab to be queryable by all the big data analytics tools. And this is really would be great.
Flatten is the word.
Yeah. And flatten the data would mean that, you know, the data is organized on this kind of data sets, like you have one data set and another one with no kind of relationships between them. When you flatten the data, meaning that you make like a common architecture where you don't make any assumption on the parentality of any kind of item in a data set, you flatten them. You can do it by graph techniques or whatever. But at the end of the day, you have, instead of a lot of data sets staying next to each other, you have one huge data set that you can query relevantly. And this could be something like great, and making like the challenge to answer in a way the challenge in as much in the query way and on the constitution of a data set.
Okay, thank you. If we have other questions, we will get back to you with the answers. We have to move on a bit on the program. Thank you very much, Bastien. Thank you, Mehdi. So I saw Christian joined us. Christian Chabory from EPITA. Sorry.
I think he was here earlier, but he must have left or had an issue with connection.
Okay, so maybe we'll get back to him just after. So here we are with the two testimonials, one from Christian from the EPITA school. We will take in a few moments if we have the opportunity to have him back. And then one from Edouard, who has a lot of interesting things to share from previous seasons' engagement. So I will jump to your presentation, Edouard, and invite you to take the floor in a few seconds. Sorry, a bit too technical. Let's do it like that. Hopefully you have. Can you see the whole screen?
Yes.
Okay, so let's jump.
Okay. So, hello, everyone. So this was in the first season of Epidemium. We made a project called CancerBaseline. And so the idea is that around the Earth, you have very different populations with different food, habits, etc. And you have very different cancer risks. And so we thought perhaps we can put the two together. We can superimpose on the map of the Earth cancer risk and sun, smoking, etc. So if we call cancer mortality, if we call it Y, and if the potential explanatory factors are called X, we will do Y equals f of X. Quite simple. After a few discussions, we discovered it was hard because if you have a lot of potential risk factors, and we know a lot of potential risk factors, then you probably want to have a lot of countries, more than there are on Earth. So you need to subdivide countries by regions, departments, cities, in order to have a lot of different cases. Each of these cases have a large population. So the data is precise up to its measure and definition errors, but we need a lot of collection. And so this is why we did a project with a lot of people, because we thought, okay, let's share the work. And so a small group at the beginning, we went to see our schools where we were in the past in order to have students. We contacted researchers to know who was interested, etc. And we spread the word around. And this is how we ended up having 200 people accepting, participating, and really 120 contributing to the data. Collection was one thing, but of course, as we discussed it, the data you collect will be very different from one country to another because of different definitions. It will be meters or centimeters, or smoking will be defined differently, whatever. So we need to align all that. And also, for example, you may know how many people eat baguette in France, but not in the US. This is okay. But for example, sometimes it's vaccination that is not present, or things like that. And so there are sometimes meaning behind wholes, sometimes not. So all this is a bit complex to analyze. However, we did do the project because we discovered that there would be a lot of potentials. So you remember Y equals f of X. If you replace Y, which is cancer mortality, by Alzheimer's risk, for example, you can reuse the whole X, and you can do this for everything. So it's potentially huge, we thought. And also we wanted to have a baseline, so a sort of regression. And if something is strange in some country, perhaps there's something to learn from it. So I will go to the main results. So the main results are, one, we have the data. So it's available on GitHub. We have 8,000 lines. So this is 8,000 parts of the world or combinations. And we have 300 columns. So this is X. And so we can alternatively use Y, which is, for example, lung cancer or prostate cancer or whatever. Two, we checked that things that are known at an individual level, you can find them at the macro level. It was not obvious. And so we tried something that we could easily check, which was a higher.
Sorry, just to fix a small technical issue. En ligne, c'est bon pour. Okay.
So it happens that prostate cancer is greater in the US when you are from African origin, because they look at this. This comes from papers. And so we checked if this was true when you take the different US states. And it's the case. And we checked also that it was true around the world. And in countries like Caribbeans or with a high African origin, you have greater ×2 prostate cancer risk. So this is just one example. It doesn't mean that it's genetic. It could be food. It could be any habit or whatever. But sometimes we are able to see things from the big Earth. And then in terms of factors that we found, so nothing really new, but at least it shows the technique, the approach works. First, smoking kills. Okay, good to remind it. Aging kills even more. Okay, cancer is an aging disease first. It starts really to go up at the age of about 50. So maybe it's linked to the immune system or whatever. Maybe it means something. And then for the rest, you remember these holes, and so we discussed with Cédric Villani. I didn't know who he was at that time. And so he is the one who explained to us that we need to regress the value of holes. And if you don't have the information about vaccination, it's probably because it's bad. The people are not vaccinated. It's not followed. And this is how, when we do this, the data makes sense. And so we have things that you see below, age, gender, smoking status, unemployment, etc. And some strange things that are probably indirect observations because we are at the macro level, and we can sometimes measure proxies from something more important, like marrying at young age for women. And then I was asked to talk about how to manage a lot of people, because it was a big effort to have a lot of people. But then we discovered soon that we were overwhelmed by all these people. And so we had really to spend time with a few of them preparing the work, right? And then we had to be available. So it's not a half-time job, but maybe a quarter-time job, right? So this was my job, to align everyone, to go after, etc. And not do anything myself, but just organize. Because otherwise people go in any direction you don't imagine, and it doesn't fit as a whole. So this is basically what happened. And then once you are well organized, you can be a lot, it's okay. But it takes a lot of time. So if you don't have a lot of time, you certainly don't want to have a lot of people because of the energy it first takes to have it well set. And we were using a Google group an email, a mailing list to announce things and entertain the whole. But really then Slack helped much. And things were collected on the Data Science Studio. But typically we felt in something at some point of time, some students who didn't have access to Data Science Studio, they moved to Excel, and we lost the connections between the source of the data and the final results. This is why at the end you have this matrix, but everything is on my computer and the computer of others in order to go back to the source, which is amazing, but okay, that's how it is. So maybe that could be my challenge this year, to try to clean this up and give it back to the community. And at the end, the prize was given to fundamental research. We found something online, and we decided to, where a lot of people can group their money together for one project. And so we found one where we gave the money. So that's it.
Maybe there's one question. I'm sorry, you can take much more. Okay, Edouard joined up on Slack, I think, recently, and I saw him on the Google platform, so you can also reach him from those tools if you have any questions further. Thank you very much. I'm not sure Christian joined us, but I will try to share with you. Its presentation very quickly. Okay. So I didn't preview the slide before. Everything is in French, so I'm sorry about that. We'll be probably pretty quick. The idea was to present the link between EPITA school and what can be done on a challenge like Epidemium. This is a quick review of what is proposed formation within the EPITA. What is at stake for future and health within the schools, basically about digitalization, creating links between IA, math, and healthcare, images, and radiology. The fact that the costs are going up, specifically linked to silver tech. DNA sequencing are lowering since the high prices that has been going on for the years 2000, of course, and there still has a few other stakes for engineers to jump in. What they are working actually is a bunch of few projects that has been delivering with NVIDIA actually. Data and imagery, of course. They are highly interested into genomics and more specifically open hardware linked to how to sequence things, and they want also to develop more projects related to this. Regarding data and portable data more specifically, they are also having a 5G challenge with the SAMU, healthcare emergencies in France that are actually going on. So those are the main themes of what they deliver into their formations. And they are highly interested into getting more highlights and more guesses about what type of project they could put their students on for the following years. So here you see a few projects also they've been working on, and a few other stakes related to healthcare. So I'll be very quick. I'm sorry, as Christian cannot really present the details of all this, but you can of course get back to him also on the Slack channel if you have questions and interest on the specific formations delivered by EPITA. So, of course, students are also participating into ECOPEN project, which is highly linked with the people in Epidemium. So yes, it was quite a bit long presentation, and obviously Christian would have been better than me to do this, but still you have a grasp of how students can be invited to join those type of events, and how interaction with companies is always good for students, but interactions with open science challenges like Epidemium are also welcome, and they are always searching for more real life challenge, I would say. So we'll now jump to presentation of specific projects. As we explained, we already have a few teams positioned on some challenges yet. And we wanted to give the opportunity for the ones who wants to share where they are right now to do it. And we have a few projects here. So we'll call who's ready first, maybe DATATEGY probably, to make a small presentation. I'm not sure, Paige, correct me if I'm wrong, Vikram is with us. So maybe Alexandre, if Paige had to left, I knew about that. Alexandre, maybe do you see Vikram in the list? I'm not sure. There's just one more people than the one we see here. So just to know when we'll make that DATATEGY have that presentation right now.
I don't see him connected. Sorry.
So we have at this point, I would say, almost 3 individual teams or people that are interested into sharing something, and also companies. Okay, so let's explain a bit what are your stakes and why you're interested into Epidemium at first. Thank you.
So I'll be quick to introduce myself. I am Luis. I am in charge of healthcare DATATEGY. So we are a startup specialized in healthcare, and we wanted to participate in the challenge. So the objective is to find the presence of HPV in cancer, understand the behavior of cancer and its evolution. So for this, we developed PAPAI. So PAPAI offers a unified deep learning architecture, and from this we can infuse any kind of data, images, temporal, tabular, and we manage it end to end, from structuring the input data of the project to constructing the layers of the deep learning model, training the model, and validating the model. So how did we do our approach for this project? So this is an image that we use this. So we are capable of introducing the sequence and its evolution in time. And for the images on the left, thanks to convolutional and recurrent blocks, we are able to extract spatio-temporal features. Then we have the numerical features, we use dense block, and categorical features, we use deep embedding and dense block. So at the end, we infuse all of these extracted vectors to build the unified deep learning framework. Then at the end, we will train the deep learning framework to predict the different classes of patients for Epidemium. Then we have the local interpretability. So AI is better if you understand the outcomes of AI. So thanks to gradient algorithm, you can achieve this task. You see the degree of contribution of each pixel on predicting the class of patient, but you can also do some simulation. For example, if you change the age of the patient, if you age his tobacco or alcohol consumption, what will happen? Good for me.
Thank you for bringing the timing of the 2 minutes almost.
Did you use any pre-trained network, or did you infuse the data right away?
So in the platform, we have more than 60 algorithms. I don't know specifically if we use a pre-trained algorithm or a specific one, but maybe Eric Shaw is in the call. or Eren. They are the one who
Hello. Hello. Is it okay, my voice?
Yes,
Yeah,
we are you.
it's
Okay. We have just started to integrate the data coming for the Epidemium challenge to the to our deep learning platform, but we had
Can
not.
just raise your voice a bit,
Okay.
Aaron, please.
We have not yet had chance to train with all of the data. We just produced some meta results, I can say like that. So this is actually, this is not a project we produced especially for Epidemium challenge. This is the generic suite, deep learning suite of our platform. Actually, this is pretty much the only deep learning platform in the market which offers the infusion of these multimodal data, like in 3 dimensions, in 3 modalities. So we just checked with some of the data, but so I can say we couldn't have chance to spend several hours with the training data. But this is the general idea, like using local interpretability by infusing all of these modalities of data, and by allowing the researchers in Roche and in other partners to understand which parts of the microenvironment contributes to certain people. Like if he is older than 70, okay, the microenvironment has much more effect, etc. So this is the generic result of our deep learning suite. So this interpretability maps offers you the microenvironment research that the biochemists and I don't know other researchers has need.
Okay. So you mean there is no tuning of the parameters? It's auto-trained, and then it's there is no specification from this point of view.
Actually, I couldn't spend several times, but this is the default auto training. You are right, but I need to spend much more time with my colleagues to fine tune the results. So we just wanted to show how our platform works on similar cases to assess the importance of pixels around the microenvironment and all, and their correlations between other parameters like age and all.
Thank you.
Thank you. I will get back. Okay. Sorry for this little technical issue. Okay, so we had a few teams that we shared with you. On the challenge 1, we actually have almost 7 teams positioned, but for some of them, the ID is not completely mature already, and they preferred to delay the presentation. We may add that we have also another school coming up in the timeline, which will be Jeddah. That would be between 5 to 10 more participants from this school on the first challenge, mostly within the 15 to the 30th of November. So that will be an interesting moment too. And we wanted to share also with you the teams engaged on the second challenge. And maybe Pascal, you are with us on this second challenge?
Yes, I am.
From NEWCLIN, yeah.
Yes.
So yes, the floor is yours if you're ready to share. I will stop the presentation from my side, which doesn't help much at least right now. So yeah, if you are okay to share a project, maybe within 2-3 minutes maximum, so we can have time for the last project. Thank you.
Yeah, thank you. I will not use any slides. So good evening, everyone, and thank you, Epidemium and Roche, for the kind invitation. My name is Pascal Echazo. I'm the co-founder and CEO of NEWCLIN, a health tech startup that develops a platform to contextualize health data by health determinants, including environmental ones, with a focus on cancer, and this to support decisions in healthcare. I couldn't join physically, so I'm just giving you here an outlook of the project. Our interest in the Epidemium challenge number 2 is to facilitate the interoperability and exchange of open source environmental data that have been proven to be cancer risk factors. And we would like to work on specifically on air and water related risk factors in the form of biological, chemical, and physical agents. And to do so, and to be focused enough, we have extracted from the monographs of the International Agency for Research on Cancer around 150 of these agents with a list of the corresponding cancers that are supposed to be induced by them. Our objective here is now to engage other people in a challenge aimed at structuring and standardizing the above data, the above mentioned data, on the French data sources and the ontology sites. First, we would be happy to leverage the experience of the OSIRIS consortium that has been previously mentioned, with a methodology that has been previously used for clinical and biological data standardization, as well as the expertise of GeoCancer in health data geocoding. As you know, environment is related to geography, and environmental related risk factors are necessarily linked to people geographic location. We have a meeting tomorrow to discuss the project in detail with these two organizations. It's probable that we will segment the tasks between what has to be done at databases level and what has to be done in terms of ontologies. The outcome of the project is a structured set of environmental items to be collected across cancer centers to evaluate the impact of risk factors on various cancers through multi-source data analysis. The work itself will be published by the different contributors, and we expect that it will allow better integration of this data in patient phenotyping and favor cancer preventive strategies at an individual and population level. And we obviously welcome volunteers in oncology, epidemiology, data science, etc. So that's it at this stage, and thank you very much for giving us the opportunity to shortly present this project.
Thank you very much, Pascal, for this involvement so far. Maybe you have a feedback from I don't know, Bastien, even if the talk will continue tomorrow, obviously, to propose also to other people. We have more than 10 people interested into the challenge 2 yet, that maybe didn't want to lead the project. And I'll get back to what you said, Pascal. We try to chunk into little bites operational stuff for you to maybe help and jump in. Do you have maybe one question or not? Okay, sure. Maybe okay for you? Perfect. So last presentation will be from ADLIN. I'm sorry about the ADLIN. Perfect. I had it right. I'll try to figure it out with the sharing of the screen.
Okay, so hello everyone. I'm Paul Rinaudo. I'm the CEO of ADLIN. Sorry, the presentation is in French as well. I'll do my best to translate it in English while we go through it. So ADLIN, we're both a digital health tech, and I'll explain why, but also a société à mission, which is a particular French aspect where we define in our bylaws the fact that we want to have social or environmental impact on our society. And we define this impact, this goal, by participating actively to the valorization of the research work. We've seen during the COVID that is a big challenge. We need to help research to better valorize their work. And this is one of our objectives. And to do that, we define that we want to help researchers, both in the private and the public sector, to better structure their omics data. We mentioned it before for more environmental data that we need to structure the data to be able to share it, to make it fair. And this is one of our main goals. So we have two big objectives: participate actively to the development of precision medicine, which goes through structuration of omics data, but also participate to the financing of the research. How we do that? Well, we develop a tool, a software, that will be made available to any researcher that will help them to structure the data from the biological question they ask themselves up to its answer by an AI algorithm, by graphic representation, to have them all during all the different process, the biology, the bioinformatics, the data science, the biostatistic aspects, and have them publish their work. So we're a young startup. We've been creating pretty much a year ago. We structured some partnerships with some different actors of the academic sector and the private sector. And here, so we're not yet into the position to propose really a project because we've talked with Mark a few weeks ago, but we want to see how we can contribute to Epidemium and maybe by helping the different teams. The first aspect would be maybe we can help them by granting access to ADLIN, to have them structure the work, to have them share their data, and to work more efficiently in their project. The second aspect is to be able to make sure that the data that are generated during the projects can be used over time. And within the framework of the project, but also beyond, and make sure that all this work and great work that has been done in the past, that is being performed, has a perennity over time. Another condition that we can propose, and it goes along with the last presentation, maybe we could help this challenge by making sure where there is some ontologies or some data that have been found and that have been structured to make their access easier to the other teams or to the Epidemium community during the project again, but also beyond, because we're sure that a great work has been performed over the time, and it would be a shame not to be able to access it over time. And if we can join a challenge with the tool, with our scientific team, we would be very happy to do that, join a team, because it speaks to us. What you're doing in Challenge 2, really, it's something that for us is very important. Open data is huge, and we need to be able to have better access to it. And we believe that there is so much data that is coming beyond, in front of us, that we need to make sure that we need to structure this data in a way that we don't live again what we're living today. And this is an equilibrium we need to find between open data, private data, and make sure they can interact now and in the future. So thank you. We're open to discuss later on in the coming days We have Slack, so be happy to speak with all of you guys.
Thank you very much. So we are at the end of this sequence. Thank you everyone for being here physically or online. If you have any questions left, of course, we still are here on the Slack. A very short word about how you can, of course, also join the challenge, maybe not having a dedicated project. We really would like you to tell there's more small contribution. The idea is that you can jump with an existing project. You can also make what you might think is a small proposal that will iterate later on. And of course, this is very interesting for us to accompany you and maybe to link it with other people or other presentations. So feel free to join and to come as you are. And of course, we like to thank again Roche for hosting this event. If you have any will, I would say, to join a team, please let us know in the chat. And once more, thank you for being here today and pursuing this idea that sharing strengths and sharing vision of openness for science is for the great benefit of all. Thank you.
Thank you. Good evening, everyone.